Hey guys, today we are going to discuss a Division 1 problem, right? So don't be afraid of Division 1 problems. Some of them is really easy to solve, like this one, right? So for this problem, we first need to discuss these two graphs. So we started from here, right? What does this two graph mean? First, we have a grid here, right? It's a n by n grid. So each of the cells in this grid has a character. It's either A or P, right? A is good, P is bad, right? So eventually, we want to change all the cells into A, right? Because only A is good. How do we change it? So it has an operation here. You can select a row of the cells. For example, this one, the green part is the selected cells, and you can move the cells to its to one of the directions. You can move up, you can move left, right, or move down, right? In this case, it moves up, right? So if you move to this place, all of the cells on its way change into the cell you selected, right? So this guy changed to P, these two guys are P, this guy is P, and this guy is A, so all the cells on its way change to A, right? And this guy is P, and all of the cells on its way change to P, right? So in this example, you select these four cells and move it to this place, right? So all of the cells in this part changed accordingly, right? So how do we find the minimal number of operations to change all of the cells into A? If the cell is already A, you don't really need to change it, right? But if it is P, you need to change it to A. So how do we find the minimal number of operations? So for example, this graph, we have several test cases here, right? The 4 means we have 4 test cases. So we have 1, 2, 3, 4. 4 cases, and this is n and m. So we are going to have a n by n grid here, and each of the cell has its character, right? A or P. And now this grid is equal to this one, right? So what's the output of it is 2, right? How do we change all the cells into A in 2 steps? So let's see. We can find a way, right? So we can move this guy first, move it all the way up to here, right? So all these 2 guys change into A, right? Because the edge is on the way of these 2 positions, right? So all of it, the edge change into A, and we can move the edge all the way up to the top, right? So all of the cells will change into A, right? So how about this one? How about this test case? So we can do it in this. We already have an edge with all the A's, right? So we can just move this edge all the way to the bottom, and all of the cells will change to A, right? And then how about this one? This one, all of the cells are P, right? So we don't have any A here, so we output mortal, right? Mortal means we are not God. We cannot change all the cells into A, so we are mortal. We admitted that, right? So how about the last case? It says 4, right? We only have 2 cells in A, right? So how do we move it? So we move A to its left and move A to its right. So we have a row of A's, and move the row to the top and to the bottom. So 4 steps in total, right? So how when we are given any grid, how do we find out the minimal steps we are going to use to change all the cells into A? So at the first glance, it's a very difficult problem, right? But if we break it down to cases, actually we are going to only have several cases, right? They are all shown here, right? The first case is all of the cells are P, right? In this case, of course, we output mortal, right? Because we cannot change the cells into A, right? And when one of the 4 edges are all A, in this case, one of the edges are all A, we can just move this edge to the opposite end, right, to here. So after the moving, we can change all the cells into A, right? So the condition is that we have one edge that all of the cells on that edge are A, right? The edge also can be this one, right? We can move it all the way to the right. Also can be this one. We move all the way to the left, right? So this is case 2. So how about case 3, this guy? So if we have A here, right? We have A at this corner, we can move it all the way down here. And now we have a row of A's. And move this row to its right, right? And all of the cells changing to A, right? So in the same way, we can change all the cells into A in 2 steps if we have A at one of the 4 corners, right? These 4 places. So we covered this case. And if one of the rows or columns is all A, like for example this column or A, we can just move to left and then move to right, right? Also 2 steps here. And another example, if we have a row of A's, we can move top and move to bottom. So also 2 steps. So we cover all the cases that takes 2 steps, right? And what about the case that takes 3 steps? So if we have one cell at the edge, we can move it to top, and then move it to bottom, then move the row into right, right? So it takes 1, 2, 3 steps. So in the same way, we have if we have A here on this edge, we can move it to left, right, then move the whole row to the bottom, right? So we cover all the cells, right? That's a case that take 3 steps. And all the other cases, like we have a random A here, and all of the other cells are P, right? So we move it to left, move it to right, then move the row to the top, and move the row to the bottom. In this way, we cover all of the cells, and we take 4 steps, right? In this way, we cover all the cases. So the most difficult part of this problem is that we need to find a way to cover all these cases. Right? So we cannot miss one case. If we miss one case, we will fail this problem, right? So we need to make sure of that. So let's see the code, right? So this is the code. T is the number of test cases, right? So we need to solve all of the test cases. And R is the row, C is the number of columns, right? And we save the status, save the state of the cases in this array, right? So if state 0 is true, that means we can achieve the final state by taking 0 step, right? If all of the cells are A, then we can achieve the end result with 0 step, right? We don't need to do any operation, right? So if state 1 equals 0 equals true, that means we can achieve the final state by taking 1 step, right? Do we still remember how do we what are the cases that we can achieve the final state by 1 step? Is one of the edges are all 0, are all A, right? So in the code, we need to check if one of the edge are all A, right? So we have a array here. C has P. C has P means one of the column has a P in it. So if C has P, 1 equals true, that means at the column 1 has a P in it. So in other words, column 1 does not have all A in it, right? And same as R has P means a row has a P, right? So if it equals to false, that means the column 1 doesn't have any P in it. That means also means column 1 has all A in it, right? So in the end, we will check. It's a little bit small. So in the end, we will check if column 0 has all A in it. This means column 0 has all A, means for the grid, this edge are all A, right? And this guy means the last column has all A, right? and this guy means the first row is all A, right? And this means the last row is all A, right? So we cover 4 edges, and if one of the edges is all A, we mark it. We can achieve the final state by just one step, right? And so as other parts of the code, we cover each cases, right? So here means if we got a A in the grid, no matter the position, we can make sure that we cannot achieve the final state by only taking 0 step, right? So at least one cell is P, so we cannot achieve the final state by taking no steps, right? So as the other parts of the code, I think you can finish the code if you are watching this video by yourself, right? So thanks for watching. Congrats on the first Division 1 problem, alright? Bye bye.